Morning. Oops. Morning, Dominic. Oh, cold morning. Hello, Megan. Aaron, good. Got a good bunch. I'm not sure how many we've got on the call. I think we were about 14. I'm frozen in the midst of defrosting our deep freeze. Thought it was a good day to do it. Could put all the old frozen stuff outdoors. Well, we thawed it out, but it's all cold out. I'm not sure what the temperature is now. What is it now? Should go and check. Just waiting for things to start here. Was minus 11 for last class. What's it now? Warmed up any? Come on, how cold is it? Minus 9. Oh, wow. Gee, big improvement, eh? All right, so let's get our show on the road here. This is just before the 8:30 class. Well, ways before. Maybe it was around 7:30 or so. Looking out my upstairs window across the city, and it was cold. That door didn't get out for a walk this morning. It was just too cold to do anything. It's funny because well, if you lived in Edmonton, you'd be saying, big deal, minus 11. It's like, it's not minus 20, minus 25. But, and it's funny because when I grew up as a kid in Montreal, and it was this sort of temperature all the time during the winter. And we still went out and played, put our snowsuits on. So here was a somewhat warmer day back in the fall, and Dora and I were out at Long Lake Provincial Park, which is not far from where I live. It's walking distance anyway, and gorgeous spot to go walking. We have so many really nice parks around Halifax, and well, there are lots in many places. And here's a nice spot that Malcolm, I don't know which class Malcolm's in, that sent me a little while back and forgot to post. It's River John, part of the province I really don't know well. So River John is on the Northumberland Strait, looking across at Prince Edward Island. The only thing I remember about there is that the water is much warmer during the summer along the strait there than it is over on the Atlantic shore. I'm more familiar. My stomping ground is much more Lunenburg County, and in the summer the water is really cold. Anyway, let's get started. So a few things. So I've spoken with the other instructors about test 2, getting mixed response from them. Many, and this is what I would expect from many instructors, that you did so well in test 1, then what's the big deal that you didn't, the grades are low in test 2. You did well in test 1, which is a credit to you. It should have no bearing on test 2 whatsoever. That on any test, I expect that I should be setting my expectations so that at least 5% of the students should be getting up in the A+ range or better, and that if I'm not getting that, then my expectations may have been too high or something of that nature. And so the top end students were getting 13, 14, I think I saw 15. I don't think I've seen any 16s on this test. And so we've marked it out of 14 instead of 16. It still only brings the average up around 60%, I think, which is, in my mind, too low. Although many people that would teach math courses would say, no, that's quite reasonable. I don't go along with that. Anyway, um, they uh, it, and even if I scale what it's out of, people that did really poorly on it, if you got 4 on that test, as some students did, then it doesn't matter if it's out of 14 or 16, you still got a very, very low grade. For those students that didn't do well at all, there's nothing we can do to change that picture. But I have given you the option. Well, it's an automatic option. You don't have to even tell me to do it. I'm going to look at your lowest test score at the end of the term, and I'm going to look at um, the discussion score that you've got. So I'm trying to post a discussion question each chapter, struggling to find different ones to fit each chapter. But there will be at least 8. We've already had 6 posted. And you get 1 point every time you participate in the discussion. And if you haven't been participating, those discussion questions are still open. So you can still go back and join it. I encourage participation because it gets you to reflect on issues that are relevant to the course. So the course is more than formulas and numbers and Excel. It's understanding and thinking critically about issues. So that your lowest test score can be replaced by a really good discussion score if you participate. And I don't grade the responses, so there aren't right and wrong ones, but generally I find you're quite thoughtful about what you have to say. Uh, I mentioned a couple weeks ago for assignment 1 that I'm going to try to reserve time every Wednesday before an assignment is due to talk about the assignment and try to address some of the questions you've got. I have been getting quite a number of them that more, they seem to know how to do it. I don't think anybody's really having that difficulty. It's just the wording that I may have used may have thrown some people off. So I'm going to go through the questions to make sure the wording is clear enough for you. The other thing is, and this was coming from other sections, not from mine, about students having issues with pivot tables on Macs. And the nobody's brought it to my attention. In my 830 class, a couple of students said they use Macs, and they've had no trouble doing. They pretty much finished the assignment. So that it seemed that there were some pivot table functions like grouping and moving were not available. I have looked on the cloud version of Office 365, and yeah, it has very little functionality on pivot tables. You can't do grouping, you can't move things around. A lot of the formatting options are not there. So it seems that the cloud version, I'm not sure about the version that you download, if it's all right. But the reports I was getting yesterday were the first I'd heard. But if you have problems, and Aaron, yeah, you're getting along. I'm not sure what the issue is. I make comment, in the past, some students have been frustrated with this course because of Excel on a Mac. And I do have to caution you, you probably already discovered this by this stage in your program. I know a lot of students really like Macs. They like iPhones, they like Macs, they like that technology. And I'm not a Mac user myself. Just I can't juggle 2 technologies. But the other thing is that when you get out into the workplace, what type of equipment can you expect to have? If you work in a government facility, it's going to be a PC for the most part. That if you work in financial institutions, insurance companies, banks, accounting firms, any of those, they all use PCs. If their business centers around that dealing with money, with dollars, numbers, counting things, they'll use a PC. If it's imagery and visuals, like marketing and advertising firms, it's all Macs. They use nothing but Macs in an advertising firm. That it's It was actually, it used to cause me trouble years ago when I deal with our ad agency and some other agencies in terms of doing our student recruitment and promotion and website development, any of that type of thing. Web developers, it's all Macs. That uh, they just they live in that world, and in terms of tools and how they do things. And there's the other that work in the sort of financial world, and they have their way. But it's almost like two cultures and two different mindsets, two languages that they don't communicate well between each other. Um, but just to give you a heads up that you may encounter the Mac users other challenges down the road. But if you're pursuing something that's very much web oriented, anything in marketing, advertising, then the Mac is the preferred tool by far. Oh, back to that assignment. So let me find it. Let me go through the things and please comment through chat on questions you've got on this. First set of questions I've been getting have to do with, when I'm doing question 3, does it use the table from question 2 and so on? That most of the time, questions 1 and 2 use the same table twice. But most of the ones subsequently, I'm asking you to start fresh, and I should have made that more explicit. And then, so if I take, let me just drag this stuff out. So this is from the 8:30 class, we were talking about stuff. So when you're starting out, you've taken your data sheet, and you've gone and inserted a pivot table, and you end up with this being something along these lines as being your pivot table. And with each of the questions, I've tried to give you an idea of what to drag and where to place it. Sometimes, though, I've just told you to format it appropriately, figuring that by that stage, you should know what to do. So the first one, it just says drag the survey to the rows. I think we're looking at gender, drag that to columns, drag ID down to values, go in and change the summary to count. So summarize values by count and it asks you to add in a chart. If you're in the Analyze tab, then, sorry, wrong one. I'm over here in my pivot table. My pivot table, if I'm in Analyze, I'd add in a pivot chart. And you're just going to build something along these lines. That in question 2, where am I here? I say format it so only male and female appear. My mistake. That only male and female were there on the first one. Last term, I asked students to do the same thing, but with data for the fall term. And in that one, we had a whole bunch of blanks, and then you had to clean up the table. This one, it turns out there's nothing you have to clean up. Everything is great, that we've got responses from everything. That the, but now make it such that we are looking at the percentage of males and females within each year. So this is that task of, if I'm comparing 2020 to 2021, I'm comparing two groups, and those are the 2 years. I am going to compare males and females, but I'm going to compare this year to this year. So when I go in here, I should be changing this to show values. In this case, I'm comparing rows, so it's percentage of row total. And get rid of the decimals most of the time. Oops, there we go. So if you've got percentages, or dollars for that matter, generally get rid of the decimals. They're not important. And so this is all I'm looking for you to give me. And you can see that we've seen a shift, that the percentage of females has dropped. Okay, there are less females than males both years, but that disparity between males and females has grown. And it's now a fairly substantial gap. surprising because quite a few, it doesn't seem that long ago where male and female were almost balanced. It was almost 50-50. We tend to be, I'm not sure if it's our roots as a Catholic boys' school in the early days, but we still don't, most universities have far more females than males. St. Mary's overall has tended to be slightly more males than females. That um, so yeah, we've seen a shift that's taken place, and then I ask you to go and do a similar comparison by where students are from, but I ask you to do it differently. So get rid of gender, put the year in the different columns, and put home in the rows. Oops, I did some filtering on this before. Excuse me, it's still left over from this morning. That so, but you'll notice if I just flip it around, it's giving me percentage of row totals, which I don't want. You should be changing these numbers here. I'm comparing again the 2 years, but now the years are in columns. So you're going to have to flip that around. Show values as percentage of column total. Okay? And you're going to find, oh, most of them are from Nova Scotia. Half of them last year. And this year, it's about 2/3 of the students. They, it's not, it's quite a shift. But I should note that's not so much, we've got fewer Nova Scotia students this year than we did last year. But we've got even more decrease in the international students, huge drop in international. So it's not just we've had a shift in change in all respects in terms of the actual frequencies, but relatively speaking, we've seen quite a shift here as well in the mix. And again, I've got to go back and change my number format so that I don't like the decimals, and you get this type of thing. This isn't very informative because these groups are so small. They're scattered around. And so what I've asked you to do is group them and rearrange them. So you could go and, if you're grouping them or moving them, make sure when you put your cursor, if you put it over here right on top of Africa, it looks like a black arrow. And over to the right, it's a cross. Keep it to the right so it's a cross. So grab that one, grab the Caribbean, China, other, South Asia, and then right click and group them together. So, and when you form a group, collapse it. So this one is, now I'm going to call it international. And I've hidden the blanks here. So I've got this, I'm covering up blanks. So now it's down and it's a simpler chart to see. Looks like that. And so you can see the Nova Scotians have increased. Relatively speaking, the international have dropped significantly. That those from outside of Nova Scotia, relatively speaking, have stayed the same. And so we've got a different demographic. If you drilled into the international, you'd find that's where we had the drop in the females. It's females from outside of Canada is the biggest group that we've lost this year. That anyway, so we've got a different mix of students, which might explain at times why we might see different patterns. But definitely the demographics have changed. What I've mentioned to you before when I asked you about what are you afraid of, a big number of students are saying they're worried about their grades. That so just in the qualitative sense, what's your biggest fear? Grades is really big on the minds of students, and even among the good students, it's not that they're afraid of failing, but of losing a scholarship. And it's taking courses in an online environment. It's an unfamiliar fashion, and they are concerned about risk. So you're into an unknown world, so there'll be risk, and it's the risk of low grades. So let's look at grade worry. That's what question 4 is about. So just throw, I'm going to actually go, and generally when I group things afterwards, I like to ungroup before I throw them out. Though I sometimes forget to do that. So I'm going to look at grade worry and comparing the 2 years. Now, these ones, it's left over from last session. You'll notice, oh no, it isn't quite, that I've got these different categories. I've got blanks, hide the blank. And there's students are more worried than they were before. Last year, about a quarter of them were worried almost all the time. Now it's about a third of them. And the other shift on the other end. But what I'd like you to do is put this in sequence. So rarely should we move down. To move it, again, put it over here to the right. So you can click on here and there should be a move, and I can move it down to the end. And this then more accurately reflects what's going on. And I've asked you to throw in gender. So drag gender in there, in here, and you're going to see that there are differences between men and women in terms of, how they worry about the material or how they're going to perform. That women appear to express more worry than men, but that pattern existed last year, it exists this year, and both males and females are more worried this year than they were last year. So if you're afraid you're not going to do well, I would think that when you're afraid of a risky event, normally we would try to mitigate any risk, try to prevent the risky event happening. And one way of doing that might be to put more time into studying. And last assignment 1, we did find that you're studying a lot more hours this year than students studied last year. So this is the one where students were having trouble supposedly on a Mac. It's definitely the question where you run into problems in using the cloud version of Office 365. So here I'd like you to take in 5 and in 6 numeric variables and make histograms. It was pointed out at an 8:30 class that I didn't say that I wanted you to compare 2020 to 2021. I did say to comment on your histograms, but I didn't say to do those year comparisons. I should have been clear on that. And the same type of thing I'd like in question 6. So keep the years there, but now look at hours studying. So get rid of this, and hours studying, bring it down, and you should get something like this. So a table that just goes on forever, and a chart that's a whole bunch of little stick men. These are still all percentages. The students have asked, what do I mean when I ask for relative frequency? Well, let me change this back. Oops, sorry, wrong spot. Let me change this to no calculation. So these are just the frequencies. So here I've got like 15 students. Okay. Oops, did I change that to money? Excuse me. I'm not sure how I did that. Anyway, hopefully it doesn't affect me later. That 15 students said they only studied 5 hours a week. or sorry, only 3 hours a week. It's not very much. 15 students, a lot of students. Seems like a lot. To be able to understand how big a number it is, you have to see it relative to something else. So a relative frequency looks at how big is 15 relative to the total. So like we've got 344 students altogether. So 15 out of 344, is that a lot of students? So that's why we would want to show values as percent of column total, which is probably where it was previously. And we are going to also get rid of those decimals back the way it was. So it's for 4% of the students. It's not a lot. Still 15 students is quite a few that spend very, very little time studying. And some don't spend any time, it seems, studying. But all these spikes are not useful. I'd like to summarize this. I'd like to group my data. So pick any of these values, go down here and say you want to group. And it says group from, yes, from -9. I'm not sure how we got that value. That's from last year, I think. Up to the highest value is 60 in increments of 10. I don't want 9. I don't even want 0 because I don't trust the 0. I'm going to put a 1 in there. And there it groups my data. Get rid of that first group because it doesn't make sense. And there we go. So this is the pattern of studying that we're getting. It's actually quite alarming for last year. About 2/3 of the students studied less than 11 hours per week. That's not very much. They, for some of them, that's probably as much time as it took them to commute back and forth to campus each week. It's not a large chunk of time, but this year we still have some students that spend a small amount of time studying. I must admit I was probably one of those in my first year. I thought I was smart enough I didn't need to study. I didn't learn my lesson until my third year, but the um, uh, although we do have some, we're seeing now large numbers that are putting in a fairly full week of studying in classes. That they're investing significant time. So this is all I'm looking for here. So we've got 2 histograms, the blue one here of last year, the orange one of this year, and I'd like you to comment on them. In the next question, I asked you to go and say, well, is it paying off? If you're studying all those hours, are you getting the grades? And this one I've probably still got grouped. So I did the same thing, grouped it. I got 2 other histograms here when grouping the grade point average. So this is remarkable. This year's class, huge proportion of the students, almost 2/3 of them, are getting better than a 3.5 GPA. You need a 3.7 overall. If you've got a scholarship right now, you need a 3.7 overall to keep your scholarship. To get it renewed for next year. At least most of the scholarships are that way. In the past, large proportion of the students lost their scholarship because they may have done well, but they didn't get an A-level performance in their first year, and they lost it. This year, it looks like, if these are correct, we've got massive number of students that are going to keep their awards, which is going to be a big hit on the scholarship budget, but they're going to have to find the money in the budget to pay for it because those scholarships are guaranteed. So this is really a good news story. As mentioned to the last class, I was responsible for scholarships for many years, and I'd get harassed by the budget committee because I overspent the scholarship budget, and it was the accountants were the ones that were getting upset with me about overspending the budget. And I just like asked them, "What business are you in?" I'm overspending because the students are being very successful. That's a good news story. Why are you complaining? And it was just, well, where are we going to find the money? That's wrong question. Anyway, but this is good to see. Uh, the 8:30 class, a couple of students asked, so students that studied more did better? Couldn't ask that on this assignment, okay, because we hadn't done scatter charts. But I suggested we go back and look at that, and I did do it. Yeah, let me just get rid of this picture for you. We went back to the data, and so if you remember from scatter charts, I wanted to look at the different groups, the 2000 last year's class and this year's class separately. And we had grade point average, and we had our studying. And if you remember with scatter charts, the variable that's on the horizontal axis, the x variable, has to be in the left column, and the y variable has to be in the right column. But I've got our studying over on the far right, GPA on the far left. So I needed to put them in a new sheet. So I did that. I put them over here. I'm not sure how well you can see it. And let me just take the filter off. So if I just look at everybody, and I then take these 2 years, insert, and I make a chart. And here it is. It's all over the place. I don't seem to see a strong pattern at all in terms of our studying here. Students that don't study a lot, some of them do poorly, sure, but a lot of them do extremely well. Those that study a lot, okay, I don't have as many down in the bottom. Not sure about these zeros that are down here. And I do have more of them up here in the top. But it's still, it doesn't look like a strong pattern. So we thought, well, maybe it's because I'm combining 2 years and 2 groups and that they behave differently in different patterns. Because remember, the last year's class was heavily down in the bottom, and you're not quite in that low studying range. So if I just do a filter and look at you, it ends up destroying my picture. It's here somewhere. I'm not sure where though, but you end up having to do it again is the best way. Hello, there it is. Still not much there, is there? Um, Hard to say that that's upward sloping, that studying more pays off. It's more complicated than that. That you may find that very capable students find that they don't need to study a lot. They find first year easy. And so they may be down here in the studying range, and they're still able to pull off those grades. And then you will find some students that are weaker students. They invest more time in studying to improve, or at least do satisfactorily, so that that relationship between our studying and grades isn't as strong as, may not be the same thing you think of. But we have seen a big change between last year and this. Students are studying more, and you're doing an awful lot better, which is a good news story. That so we've got. Oh, by the way, this one here in question 6. Let me get back to if I was doing question 6 with the grade point average. So here are my 2 histograms. Do you think I can use empirical rule here? Empirical rule says that if I take the mean value, take 1 standard deviation each side, I get but 2/3 of the values. And if I go 2 standard deviations each side, I get 95% of the values. You think it would work here? Or when should it work then if you don't think it works here? Anyone want to make a comment? I'm asking just to make sure the people are still here. I'm not talking to myself. Lots of people are typing. It'll come through eventually. Faith and Abigail are typing, but I'm not seeing anything. And others are typing. Nothing's coming through to me. It was more bell-shaped. So this sort of looks like a bell, goes up, goes down, but it doesn't keep going down over here. Like it swoops up, peaks, swoops down, but it stops. Chopped off there. This one sweeps up and, okay, maybe it's starting to turn, but if it was bell-shaped, it should continue going down on the right. So both of them are really truncated on the right. Or you could imagine them being a bell that someone hit and pushed over to the right. It got flattened against the wall over here at 4.3 is the highest GPA you can get. That so yes, these are relative frequencies. Percentages are relative frequencies. Okay, so you're okay if you've got it looking like this. You're fine. That don't use frequency counts because we have fewer students this year than last year, so our graphs look different in terms of vertical scale because they're not on the same. They're different numbers. That we had 50% more students last year than we have in the survey this year. So empirical rule you're going to probably find because it thinks it can go and step over to the right like it's a bell in both of these. The high end of that plus and minus a couple standard deviations is probably going to give you silly numbers over here on the right. It's not going to work very well. So it's still a good rule to have because when you've just got the mean and the standard deviation, it gives you a quick idea of what low and high might be. But you have to remember if it's skewed data, if it's pushed over one side or the other, then it could be that on the right side or on the left side, it gives you values that aren't appropriate. It hits a wall and it wants to go beyond it. It doesn't recognize you can't go above 4.3. And 7, I'm just asking you to comment. Can you think of any other explanation besides COVID or maybe studying or something that why things have changed so much? We have got fewer international students. We've got fewer female students. Does that explain things? You can go and look at domestic versus international or male versus female for studying and GPA and see how they differ. But I don't expect you're going to find that much. But you should always be checking yourself. When you see a big change, something that's quite striking, ask yourself, is there another explanation for this? Or what's the ramifications of that? That big changes or small changes when you expected big ones or big ones when you didn't know what to expect, those are things that warrant investigation, and you should be looking into that further. This survey, comparing the two, I found a lot of surprises that COVID has had a lot of different significant impacts on our business, our education business. And just like every other business, it's had big impacts on it in different sorts of ways. The companies that are being successful at the moment are ones of seeing those changes and finding, they keep talking of pivoting the business, of reorienting the business to take advantage of new opportunities or the changes in people's behavior or circumstances. The unsuccessful businesses are the ones that don't see how they can adapt to that new environment or are unprepared to adapt to it. And that I'm just going to show you data I've shown you before, but warrants a look. I told you I've shown you this data before and being presented by a different these are daily news feeds I subscribe to. Whoops, this is not what I wanted. Where's my, I can't show you the rest of it, excuse me. news feeds that I subscribe to that I think are relevant to at least my business, but there are ones that tend to look at data. The one I showed you before came from a it's a daily blog that's the author is more of an economist. He looks at the number aspect of institutions and what's happening, and often is looking at their financial viability. If you haven't heard, Laurentian University is in creditor protection, bad financial situation. That this one looked at the same data that came out of Ontario recently, back in January, of applications to Ontario institutions. And the guy that writes this one has to do, his area of expertise is marketing and branding, and noted that the winners in the COVID world tend to be brand name institutions, and the losers are ones that have weaker brand or are small, touchy-feely schools. And his argument is you've been shifted into taking your classes online instead of face-to-face. And in the Ontario environment, pretty much all the students are studying online this year and can expect to be online next year. And in that world, you don't have the opportunity for face-to-face instruction. So why go to a small school that is very personal and that type of thing when you're not going to get that anyway? So if you were intimidated by going to a place like Toronto or York, that why not try them out? Because what's the difference in the experience when you're doing it online if you're at a big school versus a small one? And many of the Ontario students believe that they're going to be studying online next year. And so they're going to, distance isn't a matter. They can leave home to go to school without leaving home. And schools that have very strong brand presence, particularly in the programs they want, that's where the applications are going. And the small, like the small schools at Western, the small colleges are being hit hard, but Western as an institution is not. It's succeeding. So it's really shifting these things around. And they're shifting programs as well because of health issues. Programs in nursing are very popular. Psychology, mental health, very popular. Biological sciences leading into medicine and health professions, very popular. And IT related ones, because we're in an online world. All of those ones are booming this year, whereas other programs really may not be. It's become very disruptive in terms of our marketplace, and it's trying to figure out who's going to be successful in that type of landscape. That fascinating. Anyway, I got to get going with today's stuff. Unless if you've got more questions, please pass them on. In going through looking at data, we have been, for the most part, understanding our data and then trying to figure out what it's telling us, like the ones I just showed you, which is just fairly descriptive data, but it's telling me that there's a trend happening here in terms of disrupting what products people buy and who they're buying those products from, and who are going to be the winners and losers, and maybe how your organization needs to pivot to be successful in that new landscape. So we're moving into building models to help us predict what that future is going to be. And last class, I introduced you to a data set that had to do with credit card balances of 400 customers. It's simulated data, but still it's useful for us to take a look through. And your next assignment, I'm going to try to give you some real data, though. But you'll see that when assignment 3 comes. That this data set, why would we look at predicting credit card balance? And actually, I'm sort of ahead of the game. I jumped into a data set and building a model, as I'm going to build on predicting credit card balance, without asking why I want to do it. And why? That might be, if I had a model, I could predict what would be normal credit card balances. And so when I see something that doesn't fit that, it's unusual. It tells me if this customer is an outlier and should I investigate that case. So it's helping me filter through and identify what's unusual and warrants a closer look. Maybe I'm trying to build this model to understand the behavior and what are good indicators of borrowing behavior. So if I could change something, I could get them to borrow more. That maybe I just want to know who is it that borrows. So you say, well, just look at their borrowing behavior, but maybe I want to know this when they apply for their credit card. So I haven't got historical data on them yet, but I know information on their credit card application. And just from that, I'd like to know, oh, this is going to be a really good customer. Or no, I'm not going to make any money on this customer. What sort of customer are they going to be? That what are the characteristics that give me insights about credit card balances? So we started going and finding ways of, let's pick something, look at it, and we started out using the tools we had at the time. And we had tools for comparing groups. We were using pivot tables, and we were getting into box and whisker diagrams. So we did this sort of thing here and found low risk customers borrow more, high risk customers borrow less. Maybe I want to go and understand why they borrow more, why they borrow less. I know who it is. Now I need to know why they do what they do. Um, Also looked at, well, do I need to split them into groups? Maybe I can look at them on a continuum and see, as the credit score goes up, how does borrowing behavior change? And then I'm starting to think of, hey, there's a pattern here. Can I summarize the pattern with a formula? That's starting to get towards a model. And we're also looking at other variables, which other ones might do this. And okay, credit limit, maybe income, age, education, those things didn't seem to matter. So that some of the variables I said, no, probably not important. Some of them are. That the it may be challenging, and we'll get into this after the break. How do I combine those variables together to take the information on income and rating and limit and other stuff and bring it all together to make my predictions? But let's start simple with these simple ones we can see. But we're getting to trying to describe a model. And models, you saw them in Quant 1, if you took Quant 1, and they took the form of formulas. And that's a very common way of models being a mathematical formula. So you had a break-even model, which was actually a set of relationships that told you information about price, unit costs, fixed costs, quantities sold or demanded. How does profit change? You had finance models that told you interest rates, how often you make payments, how many payments you're going to be making, how much you're borrowing for that car, and what your biweekly payment's going to be on that loan. So it relates one set of things to something else. And that's one type of model. But there are others that can be charts, pictures. They can be verbal types of models. We can have a physical one, like a scale model, that they, uh, when we were building the Sobe building, is that 25 years ago or so, that we were trying to envision what is it that they're building for us, that we had provided the architects with, this is what we need in terms of different types of functions and space and the like. And they came back with a proposal. And they did it with some pictures that gave us um, the what the front would look like, what the side looked like, what different perspectives. They called them elevations. These are pictures of the outside. Okay, and they gave us the blueprints, these great big blueprints of things. And those are like with a several story building, like looking at each floor, each slice. And if you have been in the Sobe building. The entrance, though, is an atrium that comes up 3 stories. You're looking, and it leads over to a spot that leads down to the lower level. Couldn't see that really from blueprints because they were one level at a time. It was really difficult to see from the engineering drawings what that lobby would actually look like. Today we've got visualization software that could allow you to look at rooms and how they change. But 25 years ago, we didn't have that type of technology. And it was hard to see those models. They're imperfect, okay? They only capture certain elements and not everything. And so they don't show everything. But what they do show, they show in a lot of detail. That with the blueprints, I knew where every electrical outlet would be. Little types of things like that. Maybe not important, but it showed it in a lot of detail because these they needed for the contractors. But those models take on all kinds of forms. And we'll actually use within the course some models that aren't formulas. But we're going to start there because that's familiar territory. Okay? We've had descriptive, at the beginning of the course, I introduced different data mining applications or different data mining models. Some were descriptive, like profiling ones, where you have a profile of, you're going to think, okay, what's the serial killer look like, or something of that nature. But profiling, I may have the profile of what is a really good customer look like. What are the characteristics of that? So it's a descriptive thing. That's a model that I can imagine what that customer is. I could have a model in terms of things that go together and understand the relationships between the two. And it may be two things that go together, but some go together automatically and others more of a distance. So yesterday I ordered a new laser printer for home because I have to work from home. And Staples immediately said, well, do you want a replacement toner cartridge? Because you're going to run out of ink. And so automatically suggesting those two things should go together. They also suggested some other things. I don't need them now. But yes, those two would go together maybe starting out. So, but they're working behind the scenes with a model that suggests these things are likely to go together now, and then maybe at a later stage they'd prompt me with other things that I might need in a timing sense, but they're co-occurrence type stuff. I expect they're going to send me emails down the road about supplies that they think that I'm going to need because it's a co-occurrence type grouping. Clustering is a tricky area in that some people may think, I keep thinking of students, oh, I'll cluster all the African students together, or I'll cluster all the Chinese students together. And I'm picking the clusters based on geography, like as if those students are all the same. And they're not by any means all the same. That even within China, it's a very diverse community. That even Nova Scotia, it's diverse when you think of people from different parts of the province. That when we talk of clustering and data mining, we're letting the data define the clusters for us. So these are ones that come together because they have similarities in terms of what their interests are, what they want, and that the way they form clusters in social media and social networks that are formed because of common interests that pull them together. It's not geography, it's not gender, it's not age necessarily, but certain attributes that they want to exchange and share things together. So clustering and clustering different um, uh, uh, target markets or something like that that you're looking at, well, you've let the data define those for you, which is a different way of doing things. So we've got other ones, similarity matching. We'll get to some of that later. Causal modeling we'll get into as we get into value estimation. All of these ones are we call unsupervised learning because they're describing the data and bringing it together, but we're not making predictions from it. That I think of them, if I want to make decisions and actionable decisions, generally I need to make predictions. I'm predicting this is going to be the consequence of my decision. So it's in that sense actionable. I need that prediction to be able to work forward on it. And the big ones there are value estimation and classification, predicting a number or predicting a category. And we call this supervised learning because we're going to build the model so that it is really good at predicting our target, or we're training the model to be really good at predicting that outcome. And they to think about applications of doing data analysis and data mining or modeling, or the need for different models. That so if I think in terms of a customer, for me, customer always was a student, but it's the same in most businesses. We would start out with a prospect, someone that we think might want our product or service, and that we try to reach out to them in some fashion through advertising or whatever tools are available to us. And some of them respond. They follow up, they make an inquiry, they ask a question, they come and visit us, and there's a response. This is our initial acquisition phase. There's the challenge in taking that respondent and turning them into a customer. So in my previous life, I was involved in the marketing and promoting St. Mary's. We got people respond. They came to an open house. They submitted an application. And so I got them a little bit closer to becoming a student. So I started out with this huge number of prospects, a smaller group that responded. And then of those ones, there are people like you that actually enrolled and they became our new customers. So there's a whole process then around that activation and engagement of that new customer. And our goal there is to make them an established customer, get you to come back next year. Okay? And you're going to be a repeat customer. And so we're looking at relationship management of how we're going to sustain that type of relationship. Along the way, we find some of our customers leave, some for good reasons because they graduated, others they dropped out. But in both cases, we may want to be trying to pull back former customers and bringing them back in, maybe with a graduate to get them to come back and do another degree or another credential of some sort. With a student that dropped out, come back, resume your program, and finish where you left off. That there are these different aspects of the cycle. And we can get into each one of them, these phases that we've got, has a set of questions associated with it that are really data mining applications. So if I just looked at acquisition, that very front end bit, we'd have who would be good prospects? I don't want to chase everybody. I want the ones that are most likely to become customers and good customers. Well, what's a good customer? That what would be for a student? What would be a good customer? That someone might say, "Oh, a student that gets good grades." Okay. Um, Someone else might say a student that comes back to second year. uh, Another might be someone that graduates, or a graduate that is successful, and success being defined by the graduate, because different students are looking for different things. Is it financial success? Is it personal fulfillment? Is it making new friends and networks? There's a whole bunch of different things that go into defining what they might think of as success. That so you've got to define what you mean by a good prospect or a good customer, and you would probably want to do some profiling and describe what are those attributes of that good customer. Um, and when you're looking at it, you're probably going to try to measure what how good is each prospect that you've got. So even if you've got this desired image of what you would like your customers to be, you would then evaluate each potential prospect. How close are they to your target? How similar are they to your target? How do you measure similarity? challenging endeavor, we'll see. Um, if I'm going to reach them, I've got to think of what channels are available. And 15 years ago, that was fun because internet was really starting to boom at that point. And to do uh, things like search engine optimization, which was a new term, how to attract people online. It's a whole new realm for us where we had done all our recruiting before using print media or advertising in bus shelters or in publications and television or radio. Uh, there are different channels that we've got available to us today. And even in the online world, there are many, many different sorts of channels within that. Which ones are the best ones to use for the prospects that you want? So what websites do those prospects visit? And uh, if that's how you're doing it, or are you using it through websites, or are you using it through indirectly through other media in terms of attracting the prospects? If you identify the channel, how do you do the messaging? How do you engage them and attract them to that? Can I measure whether the likelihood that customer will actually respond to the invitation I'm putting out there? Can I measure the likelihood that even if they respond, they'll actually turn into a new customer? That they'll stay a customer? What's the payoff I'm going to get? If you think about it, some of these things are classification problems, some of them are profiling problems, some are similarity matching things, that some are clustering applications. I've got some that are value estimation. They're all different data mining applications. More importantly, those are good questions you should ask, and that the answers to all of them you have to have data for. It's not just your gut feel or what someone thinks. That that without data, you have no real basis for saying your answer is right or someone else's answer is wrong if you're trying to evaluate your choices. And so it's why our decisions that we have to make going forward are all data-based decisions. And so you need to be able to think about how to take that initial question of trying to improve your recruitment of new customers. That's what that activation phase is, that recruitment phase, into a new series of questions that get down to specific little pieces. And there may be a lot of them. I've only got, I got 1, 2, 3, 4, 5. I got almost 10 here. There's probably 20 or 30 that we should be looking at in total. And each one of them may have, the answer to them may lead to more questions. And all of those questions, we need data to be able to answer. And if we don't have the data now, we've got to think about how we can acquire that type of data. So these are the different sorts of things we're going to go through. We're going to start out just looking at value estimation, and we're going to work from that and try to add in some of these other sorts of ones. We got to start small, and even with value estimation, we're going to start small. We've seen scatter charts are helpful, understanding correlation is helpful, but those are not models. Pictures, scatter diagram gives me information, but it's not an actionable model. I want something that is more specific than that. And so I'm probably going to be looking at trying to get into a formula. So a formula, our formula is going to have an output, what the credit card balance we think is going to be, and its formula is based upon characteristics of the customer. And I have many characteristics, so it could be a very complicated formula. It could be like those finance formulas for working out your biweekly car loan payment. Or they could be really simple, like you had for break even. It's best to start out as simple as possible, unless you have a good theory behind it. In finance, we have a good theory about how money compounds, and that's where your formulas all come from. But when I'm working just from data, then I don't have that sort of thing. And so I've got to work from the data and start building. Start out simple. The simplest one you can start with is to have only one predictor variable, like credit rating, and to start it with a straight line that relates credit rating to credit card balance. So the one we're predicting is the y variable, the one on the vertical axis. It's sometimes called the dependent variable or the target variable. And the one on the horizontal axis, the one we're using to help us predict, that it's sometimes called an explanatory variable or an independent variable. So in my case, I've got this simple formula: balance is intercept with slope times rating. So really simple stuff. And so it's a straight line. And I mentioned last class, I want to put a straight line through the scatter. And so how do I pick the best straight line to put through the scatter? Okay. What's the equation of that line? And if I got choices, I'd like to pick the best line. What do we mean by the best line? There you have to think about what your objective is. You're trying to predict credit card balance. So I want the one that predicts it the most accurately. Okay, if it opposite of accurate is something that's inaccurate or it has an error in it. So generally I can't make perfect predictions. So I would like the one with the smallest prediction error. So what do I mean by that? So I'd like the gap between what actually happens and what I predicted to have happen are as small as possible. Okay. So here's a few points. Here's a line through them. And the first thing to note is that the line does not fall on, none of the points fall on the line. So all predictions are wrong. So I've got 1, 2, 3, 4, I got 7 points here. And the predictions for all 7 are wrong. I've got some out here where the predictions are close. Prediction was down here, actual was just up there. Here, prediction was up there, the actual was just down there. Almost the same. So those ones are good. But, oops, hold on, doorbell. Well, working from home, challenges. Okay, so I'd like those lines to be short. So can I move that along line up or down or twist it in some fashion such that these gaps are as small as possible? Now, unless I made a wavy line that went up and down, no, I can't, not with a straight line. But what is the best line then? I could pick different ones. So look at these errors you're making. Are small errors, do they really matter? If you were off just by a little bit, would you be upset? Obviously, if you're off by a lot, you would be upset. But how do they balance out against each other? That is the cost just proportional to the size? So if you are off by 10 or you're off by 20, it's twice as big a mistake when you're off by 20. Is the impact just as big? Maybe you need to put it in context. If you were making sales forecasts and your sales forecast for the week was 1,000 units and you made sure you had 1,000 on hand, you weren't going to exactly sell 1,000. Suppose you only sold 600 and it was a perishable product. So there were 400 units you probably had to throw out because they expired. that you can't recycle them or use them for something else. Well, that's a big deal, that being off by that large amount on that bottom end. But if you were only off by 100, you may feel, no, not a big deal. I expect to have some wastage. I just don't want a lot of wastage. Suppose it was the other way around, though. Suppose you had 1,000 and you had 1,500 customers. And so you ended up with customers that were unhappy because you didn't have the product, and they got upset. They left your business and went somewhere else to get the product, and that's where they did the rest of their shopping too. And so you didn't just lose that sale, you lost a whole bunch of other sales. So being over and under, are they both the same? And being off by a little bit or a lot, it may be you expect to be off by a modest amount, whatever that is. But when you're off by a large amount, maybe that could be a devastating impact. Maybe the cost is huge compared to that. If you've got a car and you have car insurance, why do you have car insurance? Well, you've got a deductible on your policy. It says that maybe if the damage is less than $500, you have to pay for it. And you don't like to have to shell out $500, but maybe you can afford that. But if you're involved in a major collision and there was a lot of damage of thousands and thousands of dollars, you don't have the money for that. It isn't just twice as big the damage or 4 times as big. It's impossible level of damage. That's why you have the insurance to cover that sort of thing. So think of what is the consequence of the error. Is it just like a straight line? As the error gets bigger, the penalty gets bigger proportionately? Or is it more like a curve? If it's a small error, yeah, no big deal. I've learned to live with those. But if it's big, that's really painful. There's going to be a lot of blood. And so you could have it shaped different ways. You could have it balanced differently for plus and minus. It's messy, complicated. Let's try to keep this simple. That in many instances, having a linear type of error function is seen as inappropriate. Having one that's curved and it's more steep, especially penalizes big errors, is seen as being more appropriate. As the exact relationship, we don't know what it is, but yeah, we'd like an approach that penalizes big errors a lot and small errors not too much. And so common practice is to go and square things and look at squared error. Also makes the math a lot nicer. And so squared error penalizes big errors a lot, but really doesn't penalize small errors very much at all. But that's where it sort of comes from, trying to come up with a simple type of penalty function that reflects our attitudes towards errors in prediction. And so can we find the line that minimizes the mean squared error, keeps those big deviations as small as possible? So some will talk of this being a method that minimizes mean squared error, the average squared error. Others may talk of it as least squares line or ordinary least squares, in that there are other types of methods that aren't ordinary least squares. They could be weighted least squares or other types of things. But this is far and away the most common practice that you'll encounter. And it's the most common practice in defining a best line. And it's the one that we'll be using, and it's the method that Excel uses in finding the best line through a scatter of points. You're not going to be forced to use these formulas and do these calculations, but I think it's important that you do have at least a basic inkling of when it's saying a line is being put through the scatter, why is it this line and not a different line? When you look at it, you might feel a different one is appropriate. You should have a sense of why it's being picked this way and what judgments, decisions are being made behind the scenes to make this the best line. And the other thing I want to point out, just so that, again, this is sort of the theory stuff that you may park later. It's not critical going forward. That you'll be taking, if you're in the business program, you'll be taking a statistics course, Management Science 2207, and they'll talk about all this stuff again with some more theory about it. I'm not sure if they'll really add to the theory that I've given you a little bit, but they use a lot of symbols, and they make you do some of the calculations by hand. Some of the instructors do anyway. And mathematicians like Greek letters, so they would write out the true relationship between balance and rating as having an intercept and a slope, and they'll use Greek letters. Beta 0 is the intercept, the true intercept, beta 1 the true slope, but that's the underlying line to reflect the fact that points are above and below the line. They say that there's some noise there, okay, that makes the predictions less than perfect. But this is a theoretical type of relationship, and what you're going to do is take your data set that you've got and put a line through it. So this is 400 credit card customers. I've got tens of thousands of credit card customers. If I took another group of 40 and did the analysis, I'm going to come up with different values for the slope and the intercept. And so what I've got are always estimates. I've said this before, that when we're dealing with averages, with percentages, all these sorts of things, they're always estimates from your sample. And so they may be less than perfect, and there may be some error in them. And so the notation they use to write the equation of the line when you're using the estimates is the estimated balance. Anytime you see a little hat on the top of something, it generally means an estimate. And they usually use the Roman letters, the B0, the B1 for the slope and the intercept. The Greek for the theory, Roman letters for the actual things that you get. Finding that best line, that just like when you did, if you did Quant 1 and you did linear programming and you found the best product mix to maximize profit or something like that, and you had to use some tool in behind, you had to use solver with the simplex method. In finding these lines, we actually use calculus to come up with a set of formulas for calculating them. But the formulas are tedious to work with, and Excel will do that work for us. So I'm not going to bother even showing them to you. But I'll just remind you again that this is an estimate of the true line. And even if you knew the true line, it only represents the average. So I've got here is the line. This is one that's an estimate based upon that scatter of data. If I have a different scatter, the line will move a little bit, but it probably with a different data set would not move much up or down or twist in terms of the angle, in terms of being steeper or gentler. But whichever way you talk about it, the line that you get is just a reflection of the average. For someone with a credit rating of 500, then the average balance is around $800. The actual balance for an individual customer could be much higher or much lower than that. So the model is always predicting, and most of our predictions are a single number, and what actually happens is going to be different from that. Be somewhat higher, somewhat lower. And we have to have a sense of how much higher, how much lower. I'm not going any further today. We're almost out of time anyway. We are out of time, sorry. That we're building a model to describe what's going on. We're looking at predictive models, at value estimation models, that we're going to be building a more complex model as time goes on, that we might depart from a straight line. We may include more information, more variables, but along the way, we're going to use the same principles of trying to make the best predictions that smallest squared error in my prediction. And we're going to add complexity incrementally to try to improve the quality of our predictions. And after the break, we'll be getting into Excel to do that, how to find that equation using Excel, make sure we understand what all the numbers are in that equation, being able to talk about the accuracy of the numbers in the equation. Is the slope and intercept, are they accurate or not, or could they be wrong? And the accuracy of our predictions, the predictions of balance. How far off is it going to be? That is there some standard principles in terms of how to talk about how good a model is or how bad a model is? And there are different ways that is commonly expressed and measured. And we'll be getting into that. And over the subsequent week or so after that, how to get that better and better. And then we'll start looking at classification models in different ways. But anyway, you're got an assignment due this week. You've got a test on Saturday, and then you've got a break. And you don't get to see me for another 12 days. But I hope you do have a good break. The weather forecast long range looks pretty decent. And I hope you do have a good time. If you enjoy the snow, you ski or snowshoe, what have you, snowmobile, if you're in New Brunswick particularly, go have a good time. And I'll try not to bother you and let your brain have a bit of a break. And good luck, because I know you've probably got tests and other courses and other work. Bye-bye.